Okay, in this video I'd like to finish up section 11.1 and possibly we'll start 11.2. I haven't decided yet. We'll just kind of see how it goes. So anyway, we're on problem 17 there where it says Tom, Rick, and Julie are 3 of 22 members in a math class. If 3 of the class members will be chosen randomly to work in a group project, find the probability that Tom, Rick, and Julie will be in that group. Okay, so the thing to notice here is that our counting techniques are coming into play. Okay, the fundamental counting principle, permutations, and combinations that we learned in the last chapter. Okay, so I think I did mention in the last chapter that you will need to know that, some of it at least, for the things that we're talking about here in chapter 11. So I got 22 members in a math class. Tom, Rick, and Julie, what's the probability that they work in a group? Okay, well, Tom, Rick, and Julie is the same thing as Julie, Rick, and Tom, right? So the order is not important, okay, which indicates a combination there. Okay, I got 22, choose 3. 22 members in the class, and I'm choosing Tom, Rick, and Julie, okay? And of all these ways, which there are 1,540 different ways, only one of those is going to be the one where Tom, Rick, and Julie are the 3 selected, okay? So 1 over 1,540, or roughly 0.000649, would be the probability of that happening. So it's likely not to happen, of course, that these 3 would be selected, okay? But problem 18 says that a trifecta is a particular horse race in which you win by picking the win, place, and show horses, that is the first, second, and third place winners. Okay, if 7 horses of equal ability are entered into a trifecta race and Steve selects an entry, what is the probability that he will be a winner? Okay, so well, if a horse wins the race, that's not the same as the horse getting second place or third place or any other place, right? It already won the race. So switching the horses around definitely matters, okay? Which would indicate that there's a permutation, okay? So the probability that Steve selects an entry and wins is, well, there's only going to be one option there that's going to be a winning option, right? So 7 horses are running. 3 of them are going to finish first, second, third. So 7 permute 3 would give you 210. And only one of those options out of the 210 are going to be the option where the first, second, third place winners are correct. So 1 over 210 is roughly 0.00476. Okay, so again, it's likely not to happen, but anyway, we found the probability of it happening. Problem 19. 6 people, which are 3 married couples, arrange themselves randomly in 6 consecutive seats in a row. Okay. Part A, what is the probability that each man will sit immediately to the left of his wife? Okay. So for this one, you're going to use the fundamental counting principle. Okay. And by the way, there's a probability question, okay, so my answer needs to be between 0 and 1. 6 factorial would be the number of ways that all 6 people would randomly sit down, okay? So have one person sit down, there's six people, okay, now there's 5 people, okay, have another sit down, and then there's 4 people, okay, right down the list onto the last person who has to go in the last seat. That'd be 6 factorial, or 120. So out of the 120 different options there, what's the probability that each man will sit immediately to the left of his wife? Okay, well, have one of the three wives sit down. Okay, and by the way, I'm rating 6 spaces there. So have one of the three wives sit down. And now this person's date is only one guy. So whoever that guy is has to sit next to his wife. Okay, and then have another wife sit down. Okay, now 2 people have sat down. Okay, so there's 4 people left. So 2 wives and 2 husbands. Have one of the 2 wives sit down. Okay, whoever that person's date is, have him sit next to his wife. Okay, and then 2 more people need to be seated. Well, there's 1 wife and 1 husband. Okay, so whoever the last wife is, have her sit down in seat number 5, and have the husband sit next to her. Okay, and there's only 1 husband, of course. So what this comes down to is 3 times 2, okay, which is 6. Okay, so 6 over 120 gives us approximately 0.0083. Okay. Part B, what is the probability that each man will sit immediately to the left of a woman? Okay, so not necessarily a husband-wife thing, but just, so it goes girl, boy, girl, boy, girl, boy. Okay, well, the denominator is going to be the same, so 6 factorial is 120. So there's 3 wives and 3 husbands, right? Okay, so have one of the wives sit down, okay, and then have any one of the 3 husbands sit down, okay. So 3 times 3, so 2 people have sat down. Okay, there's 4 people left that need to have seats. So there's 2 wives and 2 husbands left. Have one of the 2 wives sit down, okay, and then have one of the 2 husbands sit down, okay. Whoever the last girl and boy is, have one girl sit down and then one boy sit down. So it's not necessarily husband, wife sitting right next to each other. It's alternating gender. Girl, boy, girl, boy, girl. So 3 times 3 times 2 times 2, or 9 times 4 is 36. 36 divided by 120 reduces to 1 over 20. Or 0.05 exactly, would be the probability that this situation happens. Okay, if it were a random sit-down thing. Okay. Problem 20 says that the digits 1, 2, 3, 4, and 5 are randomly arranged to form a 5-digit number. Find the probability that the number is even. Okay, so, well, for the number to be even, the number has to end in a 4 or a 2, right? And by the way, the sample space would consist of all the numbers that are between 1, 2, 3, 4, 5 randomly mixed up. Okay, so of course we're not repeating anything. Okay, so 5 factorial, or 120, would be the sample space. Okay, so out of all 120 of those numbers, how many of those are even? Well, again, only 4 and 2 are the even numbers. Okay, so the 5-digit number here has to be even, which means that it has to end in either a 2 or a 4. Okay, so there's 2 options there. Pick either a 2 or a 4 at the end. And then there's 4 numbers that remain. Okay, so 4 times 3 times 2 times whatever the last digit is, that's going to go in the 4th spot. And 4 times 3 times 2 times 2 gives you 48. Divided by 120 reduces to 2/5. Okay, so 2/5 would be the probability that the number is even. Part B, find the probability that the first and last digits of the number are both even. Okay, so the first and the last digits have to both be even. The middle 3, of course, are going to be all odd. Okay, so the probability that the first and last digits are even numbers. Again, the sample space is 120, or 5 factorial. So the number has to end in a 2 or a 4 and begin with a 2 or a 4. Okay, so if I get the beginning value first, they got 2 choices there, a 2 or a 4. Select one of them. Whatever one you didn't select, okay, is going to have to go at the end. Okay, so if I selected a 4 first, then a 2 would have to go at the end. Okay, the middle 3, of course, are going to be the odd numbers. Okay, so I got 3 numbers remaining, so 3 times 2 times 1. Of course, the last digit has to go in the 4 spot there. So 3 times 2 times 2 is 12, and 12 over 120 would give me 1/10 exactly. Okay. The homework in this section is on page 612, so be sure to look at these problems here when you get a chance. And if I just, well, let me go ahead and end right there. Okay.